Welcome to part 3 of building a top-down shooter in Unreal with C++. What you're seeing now is a preview of where this is headed. I've been working more towards features ahead of this, and I've created a small arena where enemies will spawn in, items will drop, you'll pick those up, gain power, and eventually be shooting stuff all over the place really fast, lots of projectiles, and the enemies are increasing in spawn rate, becoming more and more, until you're eventually overwhelmed and you can't really avoid them. And I feel like this is a good way to just test the overall feel of the game. Small arena, a lot going on, just see how everything is feeling as a whole with scaling included. And I think everything's feeling pretty good. I've been enjoying working on this as well as playing it, and I hope you've learned something as well, maybe gain some ideas of what you'd like to do just from watching this, and let me know in the comments if you have. Let's continue from where we left off and double check everything we've done so far. Just look it over, make sure everything is looking right, read through what we have, and make sure it's what we want. We've got a double new line here, we can clean that up, continue scrolling through, and just be reading everything. We've got some logs here we can clean up. Anything to make it look a little bit nicer, a little bit more readable, or remove any debug code that might be lingering from earlier work. We really don't need to keep the start, handling, and complete shoot logs, but since we're going to be working with it, I'll keep it here for now. And something that stands out to me is that the start shoot is actually doing quite a bit here, and I think we have an opportunity to clean this up and make it a little more intuitive. Take a look at these last 3 lines here. We get the direction to the cursor by doing a little math, and we're removing the Z to make sure that we're not looking up or down or any other direction. We just want to look straight ahead. And then we set the actor rotation. So this bit of functionality, I believe, could be extracted into its own action, probably something called a LookAt. And we can just pass a location, and we can tell it to look at a certain vector, and we can reuse this functionality a lot more, and it'll clean up this code to make it look a lot nicer as well, make it read a little bit more well. So let's head into our header file and create a new member function to hold this functionality for us. We won't be returning any values, so we'll just make it void, and we'll call it LookAt. Then we'll make it accept an f vector for its parameter, which we can tell it where we want the actor to look. With that in place, we'll get the screwdriver and we'll create the definition. Now we can head back to our StartShoot function, grab the code that we want for this one, paste it in, and make some slight changes to adapt it to what it will need to be. We no longer need cursor ground position, we're receiving the location that we want to look at. And direction to cursor doesn't make sense anymore, so we can just call it direction. Then we still want to keep the .z as 0 to make sure our character's entire body is never angling up or down. Now back in our StartShoot function, we can just say LookAt and pass in cursor ground position. And then we can delete all these lines of code that we no longer need, and now this looks so much nicer. The next thing we'd want to do is take advantage of the boolean being returned by getCursorGroundPosition, because if it fails, we're not currently accounting for that. So we can set a bool result equal to, well, actually, since we're not really doing anything with the result of this, we can just wrap this in an if statement and then only look at the cursor ground position if this is successful. And to be extra double safe, since we are using the player controller here and it is a pointer, we could make sure that the player controller does exist prior to trying to use it. So just below this, we can say if not player controller, return. And this will just kind of do nothing. And we have a very similar situation in our input setup where we are referencing input without ensuring that it is not null first. So I'm going to do the same thing and say if not input, return. And it would be a little better to actually put an error log here to inform us that input does not exist, but I'm kind of taking the short and fast route right now. Not always advised, rarely advised. I should do better. Just go on and thumbs down this video. Just get out of here. I'm ashamed. Besides that, Everything else is looking like it's in a pretty good state, not as terrible as that one thing that we're just going to move past. Alright, time to get into some more interesting parts of all of this. We are going to create an enum to represent where the character should look, either at the cursor or the direction that they're moving. So I'm looking at a little reference here to make sure I remember what we need to do. It's always good to look at a reference, as any artist would agree. Feel free to pause the video here and read through this. It provides some good information about the enums and different ways to declare them, especially around the enum macro and the use of the class keyword. Let's define our enum. It will determine which way our character is facing, so I'll go with the term e-facing mode. We'll declare it as a unsigned integer 8-bit, and we'll be starting off with two modes at the very least, movement and point of interest. The point of interest will be very open-ended, being able to use it for anything we'd like the character to look at. Then we'll add the enum macro in case we'd ever like to use this in blueprints, as well as provide some more user-friendly readable names for displaying these values in the UI. Next, we'll scroll down and add a property here to represent which way the character should be facing. It'll be an e-facing mode called facing mode, and we'll add the u property to it as well. And for the case of the facing mode being point of interest, we'll actually need to know what that point of interest is. So we'll create an f vector to represent the point of which we want our character to be looking. Then we'll want something we can use to tell the character whether or not it should be focusing the point of interest or not. So I'll go with a function called setFocusPointOfInterest that will accept a boolean to determine whether it should be the point of interest or not. I'm choosing this route because we only have two options in the enum, movement or point of interest, and I feel like this simplifies the interface a little bit. So let's make use of our handy dandy screwdriver and create the definition for this. And the implementation for this can be pretty straightforward. If focus is true, then we can set the facing mode to point of interest. Otherwise, we can set the facing mode to movement. Now we're ready to take advantage of whatever facing mode is set to. So we can scroll down to our tick function and set this up. We can say if e-facing mode is equal to point of interest, then look at the point of interest f vector that we have. And right now, if facing mode is equal to movement, we don't really need to actually do anything because our movement component is handling that for us. Now let's update our shoot member functions to support our new facing mode. We no longer want to look at the cursor ground position at this point, we want to set it to our point of interest. So let's remove this LookAt and set point of interest to cursor ground position. And we don't really want this in StartShoot anymore, we want it to repeatedly happen while we are shooting. So let's grab all this logic and move it into the handle shoot rather than the start shoot. Now that we're setting the point of interest to our cursor ground position, we need to tell the character to look at the point of interest. So when we begin shooting, we can say set focus point of interest true. Then we can move down to complete shoot and do the opposite. Set focus point of interest false. Alright, so let's recap what we have so far. We've got the start shoot setting focus point of interest to true. We have the handle shoot, which is setting the point of interest to cursor ground position, and then the complete shoot, which is setting it back to false. And these are all just passing a boolean, which sets facing mode to point of interest or movement. And then finally, we have the tick, which is checking the facing mode. If it is point of interest, we look at the point of interest. I think this all looks pretty good to me, so let's see how it works in game. Back in Unreal, we do a live compile and start up the game. Now when we're moving around, we can click and hold, and our character will continuously face where our cursor is while holding the button. We let go, it goes back to facing the direction we're moving, and then we can click again and take over that control again. Seems like it's working pretty well. Maybe even an orca. Now that we've moved this logic into the handle shoot member function, it's going to be called a lot more frequently. So this logic here is going to be called many times in a single second. So when we cast to a controller here, we're doing a lot of unnecessary work that we could be saving ourselves. Let's save a cache reference to our simple player controller on our class. We can head over to the header file and create a reference to it here. We can paste the type in, forward declare it so we don't need to include the reference to the class here, make it a pointer, and we'll name it PlayerController. Moving back to our C++ file, we can remove this line. We don't need the type included, but we can cut the rest out, delete it, move up to our begin play, and create the reference here. And since we named our cache reference PlayerController, we can just paste this in and it'll work. So now we have a persistent reference to our PlayerController whenever we're handling shoot, and we don't need to cast or get controller over and over again. Let's live compile our changes and make sure we didn't break anything and see if everything's still working the same as it did before. And it looks like it is. So we're all good and everything's a little bit better now. On to the next step. Alright, now let's add a little extra visual to help us understand what is happening when we're holding the left click. We can draw a debug line to represent the trajectory a bullet would be taking, and we can use the location, which we'll need to get from our actor for the line start. And we'll actually need to use this again, so let's pull this out into a variable that we can reuse. We'll make an f vector, call it location, and set it to get actor location. Then we can pass that in for the line start, and then we'll need the direction that we're facing, which will be the forward vector. So we can make another f vector, call it forward, and set it to the actor's forward direction. Then for the line end, we can do location plus forward times 1000. And that should give us a good baseline to see how we're looking. And for the color, I'll go with purple. And it will not be persistent this time, so we can say false for this. Then lifetime, we'll just provide the default value of -1 because we do not want it to persist for very long, just one frame. Depth priority, we'll just say 0. And then the thickness, we'll try 2 and see how that looks. So let's live compile this code and see what we're seeing. And it's a little thin, but overall, it's doing the job. I think I'll make it a little bit thicker though. So back in our draw debug line here, we'll go to the thickness setting and update it from 2, just add a 0, make it 20. Live compile, and let's see what it looks like now. Yeah, big ol' laser beam. So now at this point, you could use the same logic we used to create this line to create ray traces and actually hit things if you wanted to. And we will be getting to that eventually as well. Very quickly, I'm going to set up a few obstacles for us to work with, a very small room, some walls, just a very simple area for us to move around in and see what we may notice or find about what we currently have. I'm going to set the location snapping to 100, drag out a box from the geometry section of the actors, and use Shift plus 7 to enter brush editing mode. And then I will very quickly throw this room together for us to mess around in, a simple playground. And there we go, our simple room. Let's see, oh god. I apologize on behalf of simple character. Oh, he's doing it again. Oh god, I am so sorry. I'll have a talk with him. Alright, so let's fix this problem. It's actually a part of the SpringArm component on our simple character. So let's open up the simple character blueprint and see if we can find it. We can open up the full blueprint editor and go to our SpringArm component. Then under the camera collision section, we can look at do collision test. If true, do a collision test using probe channel and probe size to prevent the camera clipping into level. This is what's happening currently, and if we uncheck this and try it again, we'll see how it acts differently. And now it is no longer zooming in, the wall is no longer pushing the camera, and ensuring that nothing is ever between the camera and the player. So now let's do the proper thing and set this up in our C++ files. So I'm going to go back into the blueprint and revert this to its default value of true before we do this. So now that's back to true. Compile it, save it, and we will head into the C++ file to make this a true default for our purpose. Here's our SpringArm component where we already have a lot of our other defaults, and we know this is a boolean that is a do collision test. We can find it that way and set it to false in our constructor. A quick live compile of the code, and back into our simple character blueprint, recompile that as well, and we can now see that the default is false for our blueprint, just how we like. And I always like to give it another playthrough, just make sure everything is working correctly as expected, and it indeed is. We can still do our little purple laser beam, and everything's looking good. We've moved our character around this map a bit. I think we've discovered everything we can really discover from this current arrangement. So let's see what we can do to make this a little bit more different, unique, and what we can discover to fix from here. So now I've given our map a little bit of height to work with, and if we look at how the point and click and look is currently working, it all looks pretty good. But if we add a little bit of height, you can see that it's no longer as accurate as it was. And if we go higher up, it gets even further off. And this is because of our calculation not taking in the distance to the ground currently. It's using a hard-coded 0 in place of what should be the current ground level of the character. So let's head into the code and fix that real quick. So here's our hard-coded 0, and we want to update this to be whatever the character's current ground level is. To achieve this, we can add a new parameter to our getCursorGround position. We can take in a float and call it ground Z. We'll update this in our header file to match, and then update the 0 to be the parameter of ground Z. Then the last thing to bring this all together would be updating the member function call in our simple character. So let's find where it's at. It's pretty easy because it's currently got an error as it's missing that ground Z parameter argument. And since we're modifying some existing code here, it's good to always look at what we currently have to make sure we don't do anything a bit sloppy. So in this case, we need the character's Z vector from its current location, which means we need the location. And if we look on line 99, we are already declaring the location, so we can actually just pull that up and use it to get this, and it'll be a little bit cleaner overall. So with that moved up, we can pass in location.z, and we don't really have to do too much else here to get what we need. Oh, and there's one additional thing I forgot to do. We currently have a bad formula here, as we need to wrap the ground z minus world position.z, as it should happen prior to the division of world direction.z. Now we should be pretty set. Let's head back into Unreal, live compile the code, and see how things are functioning. And we'll start off with an initial test on the ground. Looks like everything's still working well there. And a little higher up, seems to be pretty accurate again. And all the way up here where it was really off, everything is still looking good. So now we have a proper aiming at all levels of the ground. That seems to be working pretty orca. The next thing that stands out to me is how quickly the character can turn when making very sharp movements. If you go from one side to the other very quickly, it kind of just jumps, snaps to that position, and it doesn't feel very natural. So let's adjust how that's being handled to give it a bit of a smoother rotation, regardless of how quickly the mouse position actually changes. I'm thinking that this functionality would be a perfect addition to our LookAt member function. Since it's repeatedly being called as we're holding down the mouse button, we can interpolate that rotation over time as it's being called from the tick function. So I'll add a boolean here, and I'll name it smooth rotation. And it's worth noting here that I'm about to try something that I am unfamiliar with. I'm going to attempt to set a default value to this smooth rotation. And while I'm very familiar with doing this in other languages, I'm still learning C++ here. And now it looks like doing this has completely broken all of my syntax highlighting, more or less, throughout all the code. As you see, everything is now plain white text. apart from the native types like the booleans, the void returns, floats, etc. So I try a few things here. First, I try removing the boolean with the default value that I set. It's like, well, did that just break everything some reason? No, it's still broken. Well, maybe I can do a rescan solution. I feel like that could maybe solve this. And it also doesn't solve the issue. So I'm going to remove this line that seems to have broken everything and try something different. In my Unreal Project directory, I'm going to generate Visual Studio project files from the uproject file. And lo and behold, success! The syntax highlighting is back. The issues are fixed. Let's see if we can do this without breaking it now. We'll strangely start by typing the exact same thing which broke it in the first place. A boolean of smooth rotation equals false. And while we do get the error, we do not break all the syntax highlighting, so I think this is a slightly better start. I'm going to move into the header file now and update our LookAt to have the same property of the bool smooth rotation equals false. And it looks like those errors are gone, so I feel like I'm on the right path right now. So let's keep trucking forward and see where we end up. Now we want to use our smooth rotation, and we'll wrap this in a conditional to say if we're not doing smooth rotation, we will just set the actor rotation as normal, because that's how it's currently working, and we'll return from any additional functionality we're about to add. For the case of smooth rotation, we'll build an F rotator that will be a partial rotation from our current rotation to the target rotation, and we'll achieve this with R-interp2 from the F math library. We can see that it takes 4 arguments: the current rotation, the target rotation, a delta time, and an interp speed. So knowing we'll need the target rotation, which we're already doing on line 119, we can take out the direction.rotation from inside the if statement and capture this in a variable of its own called target rotation and utilize this for both possibilities. So now that we have our target rotation ready for us, let's fill out this R-interp2. So for the first argument, we can just use get actor rotation to get our current rotation. Then we have our target rotation ready as the second argument. And now we're running into something that we do not currently have. So we'll have to adjust our LookAt member function to accommodate for this. We can accept a float of delta time as another argument, and let's update our header file as well, and we'll do the same thing where we provide a default value of 0.f. If we're not using smooth rotation here, we don't need a delta value. And now we have a delta time value to pass in for our delta time argument. And again, we're hitting the same situation where we need something we do not have, so we can provide another argument here for rotation speed. And we'll do the same thing that we've done for delta time, provide it a default value of 0. Now that we've completed our partial rotation call, we now have a partial rotation. The only thing left to do is to set it in the same way we were doing above, but instead of using the target rotation, we will use our partial rotation. Now with our LookAt member function enhanced with new functionality, and functionality that maintains the original functionality without needing any alteration, we can now alter the existing call to LookAt to incorporate our new smooth rotation. So we can pass in true for the smooth rotation, delta time from our tick function, and we can try a rotation speed of 10 for now and see how that feels. Let's head back over to Unreal and live compile our code. Build failed. Remember when I said I was going to give something a try? I know, I could just look up C++ default arguments, but I do enjoy some raw experimentation when I have the freedom to do so, just to really solidify the moment and remember the struggle or wall that I hit to make it stand out more in my mind. And then I think it is good to look up the documentation and see what you didn't learn through the process of trying to do it yourself and what you might have missed or could use later in the future. So in this case, I'm going to use a reference that I understand to have default values, which is the draw debug line. We've used it many times. We see that it has default arguments for persistent lines and every parameter following. So I want to control click on draw debug line to see the declarations for this function. You can also right click on draw debug line and go to definition. Now at the bottom we see those definitions and we can see how these are being declared versus what we're doing. We can look at these signatures and understand more about how they've set up their default values. And we see that this first file is the C++ file, and it does not have any default values. And then the header does show the default values. So let's try copying this, removing our default values from our CPP file, and then only leaving them in the header file. We'll live compile the code again, and success! We did it correctly. Yay! Now let's see how it's looking in game. Oh yeah. Oh yeah, look at that. That's working really Orca. It's super smooth. You can adjust the rotation speed to your liking, but we do see that we now have another issue where moving is actually influencing the direction a bit. It's trying to interpolate fighting the orient character to rotation from the movement component. So as we add things, we get things to fix. Features sharpen features, as they say. Fortunately, this is a pretty easy fix for us. We have the set focus point of interest, which we're using, and we just need to adjust what is happening when we set the focus point of interest to true. So let's head into here and see what we got. If focus is true, we're setting the facing mode to point of interest, and we want the character movements B orient rotation to movement to no longer happen while this is the case. And in the case of focusing movement, we do want this to be true. Yet another live compile, and let's see what's happening. Alright, look at that. It is no longer fighting the orientation of the movement, and everything is looking pretty smooth and nice. Ugh. Now we've got pretty much everything we need to really take this off any direction we want. We have a point of interest that we could really use for so many different things. It doesn't have to be for making the character look at the mouse. We could set a point of interest to a character that is talking or some other thing that is happening. You could really do so much with this. It's pretty open-ended, which is pretty nice. So now we have a lot to work with. You really just kind of pick your direction, start adding whatever comes next, and have some fun with it. The next step would be adding guns, enemies, anything you can think of, and just taking it and making it what you want. There's so much possibility here. You've got the foundation, now you just get to build and go. If you do have any thoughts or ideas of what you would like to see, what you would like to do, let me know in the comments below, and I will help make that happen through a video to help you reach that point. Until then, like, subscribe, leave a comment, let me know what you thought about this video, or if you just have some feedback for something I did and how I could do it better. Or if you just want to see this go in a certain direction, I'm open to ideas and we can do something together. So now I shall say goodbye. Get my steps in. Get my steps in.